Okay. Welcome to lecture 20-something ridiculous, 5, I think, of CS160 / some other people. How are you guys doing? Holding on?
Yeah.
Keep on keeping on? That's good. Anybody else go and see Alt J last weekend? Alt J was fun at the Greek. What's that? I gave away my tickets Thursday. I went on Friday.
You're planning on both days?
No, they opened the Friday show late, and I bought Thursday, and then I was like, nah, I could go on Friday. That'd be much better. All right, welcome. Oh, this is going to be rough. All right, when my voice gives out in the middle of this, we will just go slide by slide. Everybody gets to present one slide. So what we're talking about today is human learning and learning technologies. And this is going to be kind of a long, meandering journey to someplace. I'm not totally sure where we're going. But I think it ends at my dissertation. So that'll be fun for everyone. But of all the things we've talked about in this course, with the exception maybe of connected devices and such, this is what I actually know the most about. This is what I did my dissertation research on back in my PhD days. And I think it's really super important for everybody who takes a UX class to know kind of some fundamentals of human learning. And the reason for that is that every single user you come into contact with, everybody that touches your product is learning it, right? They are picking it up, they don't know how to use it, and they have to figure out how to use it. So they are, in a very real sense, learning how to use your UI. And knowing something about how people learn can really impact the way that you design and the way that you build new technologies. So having just a little tiny bit of background in that space is really important, I think. So if somebody had to put it in one sentence, how do people learn? What do you know about human learning? Yeah.
By observing.
Okay, by observing. Some of that. Yep.
By actually trying.
Okay, by trying, by doing things. Other ways we learn? Okay, by repetition, by practicing things. Yep.
Failure.
Okay, by failing and learning from failure. Agreed. Yeah. Okay, so motivation is an issue, like feeling compelled to tackle some problem. So this is interesting, I think, for a number of reasons, but one of them is that our understanding of human learning has really changed a lot over the past century plus. Unlike many of the kind of social sciences which have stagnated a little bit in the 20th century, human learning, like education research, really exploded in the 1900s. And so we go all the way from like the social constructivist John Dewey, Lev Vygotsky, who's my personal hero, era, up through experiential learning and Bruner and scaffolding and Papert and constructivism, and all the way over into Miss Marsha Lin, who was on my committee and kind of was the pioneer of technology-enhanced learning through the 90s into today, faculty here at the Graduate School of Education. And there's this constantly evolving notion of how people learn and what it sort of means to cater to the way that people learn. In contrast, if you look back at 1350, at what kind of university education looked like, it looked like this, with a bunch of people kind of sitting in seats looking at one person standing up front who is lecturing out at them. And if you move forward to 1909, it looks kind of the same, and 2009, it looks kind of the same with PowerPoint at the front. If you look around here, we are kind of still stuck in this format of we're going to get a bunch of people into a room and I'm going to preach at you. And no one at this point thinks this is optimal. That's kind of well understood. But there are a lot of barriers pushing, barriers to change, barriers to entry into kind of more compelling learning methodologies. And we'll talk about a few of those barriers and then some of the ways that people have tried to get around them over the course of this lecture. But why is a lecture a problem in the first place? Basically, students learn best when they're actively constructing knowledge, when they're doing things, when they are challenging themselves, asking questions of themselves, and like really engaged in the learning process. And there are people that are good lecture learners. Like, I'm going to guess that at this point in the semester, those of you who are still coming to lecture kind of get something out of it, I hope, right? But many people don't, and that's why I really don't hold it against people that they don't come to lecture. Like, some people get something out of this and some people don't, and I want the people that do get something out of it here. But as an education system, we are absolutely losing students who are capable of learning, but not capable of learning from lecture, not capable of learning from this environment. And so the question is, how do we get more of these things, reading, audiovisual, demonstrations, discussion groups, practicing by doing, and peer learning, teaching each other, into the curriculum without being kind of too disruptive to the status quo? So it's all about active learning and pushing in that direction. And this is kind of the notion of how people learn at this point, is that learning is a process of building new knowledge using existing knowledge. It's an actively engaged student takes what they know about the world and really builds on top of that by latching on to the things they already know and constructing new ideas out of those concepts, testing them and seeing if they're true about the world. And so something that comes up a lot in user interface design, we have already talked about a bit in the context of metaphor, is this notion of transfer. And what does it mean to take your existing knowledge and apply it in a new setting? And so learning is kind of fundamentally experiential. You are most effective as a learner when you connect something new that you're learning to your existing real world, real life experiences. And the knowledge that the learner already has from those experiences does indeed serve as the foundation for new knowledge. And so we're constantly building. We're building on to what we already know and learning in that way. And if there's one thing to take away from this lecture, it's this: the sort of fundamental result of education research over the past century is that learning is fundamentally social. Every single person basically learns only by talking to other people, learning directly from other people, or interacting with artifacts built by other people. Okay? If you were out on an island on your own and had never had any contact with the rest of your society, you would have a great deal of difficulty learning calculus, let's say. It just doesn't work that way. You might be able to learn a little bit, but not very much. Like, really, the vast majority of what we learn as people, we learn from each other. And there's this notion of the zone of proximal development. This is one of Lev Vygotsky's contributions to the field, that states that if you roughly divide the world up into things that a student knows how to do and things that a student can't do, there's some middle ground where they are things that the learner, the student, can do with the help of a teacher, or with the help of a more capable peer, or with the help of an artifact built by a teacher or a more capable peer. And it's in this section of the world that learning happens, that people improve, that people become better people, is by interacting with other people and the things that they know. And so this happens every day. This happens in the classroom where I stand here and I yell things at you. I know things over here and you know things over here, and I'm trying to hit this zone. But it also happens like at work, when you work with a senior person on your team, or even with a junior person on your team that happens to know something that you don't know. They're dragging you through this zone of proximal development, and that's how people learn. In the context of kind of traditional education, we have a word for this, for the things that we are purposefully putting out there to help people through the zone of proximal development, and that is scaffolding. So instructional scaffolding is the assistance that helps learners do the things that they could not have done on their own. And so if we, give you some slides about contextual inquiry and then send you out into the world to do a contextual inquiry, those slides were the scaffolding. We were giving you some information about how to do this process and then telling you like, all right, now the way to really learn is to go and engage in it, like go out there and do it. We have your back, but if you want to learn, you just kind of have to go try it yourself. And so that is instructional scaffolding. And broadly, the goal is to progress in understanding from concrete to abstract. And this is a notion that you kind of intuitively get. Like, if I were to take a child, again, and hand them a bunch of rocks and be like, all right, I have 2 rocks and I've got 6 rocks, and now I put them together, how many rocks do I have? That's very concrete. Like a relatively young child, once they know about numbers, can answer that question. They can say, all right, you got 8 rocks. But it's much harder to kind of abstract that out to numerals and math, and then out to like abstract classes of like integers and things in terms of algebra. And so the whole kind of process of learning as a general rule is about guiding people on this journey from really concrete operations up to abstract understandings of what's going on in the world and what's important. And we do that by providing instructional scaffolding to help people move along that journey. Make sense? All right, that's your like 10-minute background on everything we know about education. And now we're going to use that to dig into some of the kind of classic famous toolkits for teaching. All of these are in the constructivist sort of school of educational philosophy. And the notion of constructivism is that it's a theory based on observation and study about how people learn, that says that people construct their own understanding and knowledge of the world through experiencing things and then reflecting on those experiences. And just in case you're actually confused by my graphic, constructivism, the Russian art movement, which this is different, unrelated to the constructivism that we're talking about. So there are some famous ones that are out there, and we're just going to kind of walk through the past 20 years, 25 years at this point, of learning technologies and see where they're going and see where we're headed. And if you have any questions about any of these, like, stop me. Like, I have a lot of details on these slides, but I don't really necessarily want to just talk to the slides. So if you have any questions about any of these things, I know this stuff very well. Feel free to ask me questions. But the granddaddy of kind of constructivist technologies is Logo. Who here has ever used Logo in like its pure form? So like walking the turtle around and rotate 90 degrees and pen up, pen down sort of thing? A few of you. Going forward in Lego history, who has done Mindstorms? Okay, so that's a Lego by Logo Mindstorms. Who has done Scratch, which is kind of the next descendant there. Okay. And then the crazy ass Berkeley Scratch, whatever they're calling it these days. It was Build Your Own Blocks. I think it's now something else. Snap. I like it. All right. So if you go way back in time to the mid-60s, 1967, to Seymour Papert, who was kind of the granddaddy of constructivism, he had studied with Piaget, who, if you don't know, I didn't bother putting anything about Piaget in here, but Piaget is like the guy who was like, education should be a science, and kind of made it so. He's famous for the stages of learning, where children move from kind of concrete to abstract reasoning. Anyway, so Papert came along in the 60s and decided that people would learn math concepts a lot better if they had a like physical analog to their abstract mathematical thing they were learning about. And so he invented this thing. And if you don't know, like, this is true. Like the logo, the turtle was a thing. Like before the logo with the turtle, with the graphics and you draw the lines, it was a real thing that like ran around on the floor. and it had a physical pen, and it could put the pen up and down, and it would draw on a big piece of paper on the floor, which is actually much more instructivist than logo on a computer screen. Like to have the physical thing there that you can inspect and like poke at is very interesting. But anyway, it involved control of this robot and driving it around, and you could learn about math, and you could learn about how shapes get defined and parabolas and things like that. Very successful. It went out into the world kind of in the 70s in New York City and famously in Dallas. And then, Mindstorms was this paper that, or book that Patrick published in 1980 that was an entire curriculum around logo. And we're not talking about computer science here. We're not talking about programming. It was a mathematics curriculum, mathematics and physical sciences curriculum, all built around logo. And the idea really was that you could get in there and you could build these like simulated situations where students could play around and learn about how kind of physics works. Logo for Lego began in about 1984 with Mitch Resnick, who was at MIT at the time, and is another one of these kind of granddaddies of constructivist technologies. So microworlds came next. It's still logo, and this is really getting into this notion of how do you do this like snap pieces together in order to do functional data flow sort of programming. And then in 98, finally, Lego introduced Mindstorms, which had this same like brick-based interface for kind of dragging and dropping things. And so what happened to Logo? Logo was widely deployed in schools in the 90s. It's primarily a programming assignment, and people did much of the programming work. And that's kind of what killed Logo eventually, is that it started getting treated in schools more like a programming assignment and less like a science class or less like a math class. And so these kind of haphazard curricula that just went out and taught people how to program wasn't actually the idea. And it led to some pushback against Logo by teachers in the US. Variants of Logo are still going strong elsewhere in the world, but it is very telling, I think, that like the descendant of Logo that is most alive is Scratch. And we think of Scratch, I think, much more as a tool to teach people about programming than we think of it as a tool to teach people about physics, which is very much not what the original intention was. It was very much intended to be this toolkit for learning about other things. And this is the notion of these micro-worlds. So a micro-world is a physics simulator or a whatever simulator built in Logo where people can play around, and Pepper referred to it being a sandbox where learners could engage with the environment and kind of see how it works. And you're supposed to discover new principles. So for instance, say that you give students a physics simulator where they like shoot a ball out of a cannon, right? And you say, all right, over here is a slider, and when you change this slider, like gravity changes. We're going to change the force of gravity. And your hope is that students will ask themselves questions like, oh, what happens at the extremes? And like, what if I change the angle? And like, how does the parabolic arc of this thing change as gravity changes? And you're wanting students to like really engage in these questions. That's the goal, so that they can learn something about the underlying physical system. One of the famous examples was they had this like ball moving simulator where you could change, so force equals mass times acceleration. They had this like little widget that lets you like switch that around, so you could be like mass equals force to the acceleration, or whatever, and see how the world would be different if you were to mess with those physical laws. Fast forward a little bit, and we get Boxer, which was work by Andy DeSessa over here again at Berkeley in the Graduate School of Education, who was one of the pioneers of Logo. He wanted this to be kind of more explicitly programmatic while still being kind of more visual and fun. And so he built this kind of visual programming language that uses nested box to represent the procedures. And so it was a more explicit programming model. And it turns out that it was actually a little bit easier to learn than Logo. And this is kind of where Scratch came from, is that like Boxer built on top of Logo, Scratch built on top of Boxer. These things just keep going. So strengths of Logo are that it's very versatile. You can do things quickly, avoids a lot of details, and it helps keep things in the abstract. The downside is that in general, somebody else is programming the simulations. Like you're not going to hand the 4th grader just Logo and say like invent physics. It's a nice thought, but it just doesn't really work out that way. And then it also tends to be a little abstract in the sense of how tightly tied is it to your own motivations. There's something about, and even today, although it's weakening, but in the 90s, it was true that there were like some students who just rebelled against the computer. Anytime the computer was in the classroom, it was like, if it's on the computer, it's not real. Like I can throw you a ball and that's a real thing, but if I throw the ball on the computer screen, that's not real. And so people had some motivation issues around that. And then there was this fear by teachers in the 90s, which of course it recurs with every instructional technology, but teachers were convinced that like Logo was going to lead to all teachers being fired because Logo would teach the students, and why do I need to be here if Logo is the teacher? That might have been a little premature, that concern, but it was there. And then the last bit is that it's not really a learning management system in the sense that it doesn't help learners manage their own progress. It doesn't help them kind of pause and reflect and think about what they're learning. And so that's on the teachers. So that's Logo. Logo has a special place in my heart. It taught me programming when I was in 3rd grade. I drew stars and things and decided I wanted to be a computer scientist. So I appreciate that it's still part of the zeitgeist, but no longer completely relevant. New topic. In a different vein, we have kind of collaborative software. So these are tools that allow learners to work directly with experts. Why might we want to do this? What have we learned today that might make you think that collaborative software might be relevant to learning? Yes?
You said learning is entirely social and getting in touch with an expert will help you on that.
Indeed. So there was a big boom in kind of people attending schools in the 90s. It was kind of the echo boom from the baby boom. And lots of new teachers got hired, and some of those teachers weren't very great. And we're still kind of dealing with the repercussions of that today. But there's this inherent notion in the zone of proximal development and in social constructivism that if no one in the room knows anything, no learning will happen, right? Like if the teacher is not better informed about a topic than the student is, then it's impossible for learning to happen unless the teacher has like artifacts that are better informed, but that tends not to work out very well. And so there was this push towards collaborative software where students could be put directly in touch with experts. And there's all sorts of these systems. The most famous one I would say is CoViz, which is what this is here, which is this tool for building collaborative visualizations of data. And so it would be, you get a bunch of students together and you give them like video chat with each other. And you have them talk about like what happens if all the places in the world that were hot are suddenly cold. Like what would that do to the world? And then they do that and like the winds change directions. And it's interesting. CoViz included this mentor database that teachers could tap to talk about advanced topics, where they could be like, all right, today is geology day. And that one day they would have a geologist at the U.S. Geological Survey sitting at their desk, and they weren't like lecturing or anything. They were just there, and like they had like a camera on them while they were like doing their work. And if the students wanted to, they could be like, "Excuse me, Mrs. Rock. I have a question about geology." And then Mrs. Rock would be like, "Oh, okay, tell me, student." And they would have a little conversation about it. And then everybody would move on with their day. And so it was this very like lightweight way of engaging experts in the learning process about whatever the relevant topic was. And so it used video conferencing and screen sharing and shared document editing and all the things that we kind of think of in terms of collaboration software today. And this is one thing I want to note. Like, there's this, you see certain parts of our industry that tend to be forward-thinking only because they have no choice, because they're like fighting to survive, or they know that what they're doing is bad, or there's just a lot of competition. And so like video games are traditionally seen in that light in HCI. Like, you know, people making video games tend to be kind of on the cutting edge because they have to be in order to survive. Educational technology is kind of the same way. There's a tendency to kind of branch out in directions that were not thought of before. Discoveries that then kind of get incorporated back into kind of core HCI. So collaborative document editing got big in education kind of well before it did for the masses. All right, TVI, probably the most famous instructional technology project of all time. It's called Tutored Video Instruction, and it was James Gibbons at Stanford back in the 70s. And the idea was that they recorded lectures. So they would have somebody lecture to a room of people, and they would record the lecture. And then they had a second class that wasn't allowed to go to lecture. Okay? And they would take groups of like 5 of those students, and they would sit down with like a TA and 5 students and a VCR. VCR. It was a thing where you played tapes. That's fine. And they would sit there and they would watch the lecture together. Okay, so 5 students, 1 GSI videotape of the professor, and any one of the students could pause whenever they wanted to, or jump back 30 seconds or whatever. And they could pause and they could have discussions and they could ask questions of the GSI. Okay, so it's kind of like watching the webcast of my lectures if, you know, Shayna were sitting right next to you, and you could ask her questions while you were watching the webcast. And so they did this in the same room, and then they also did it in a distributed way, DTBI, which was a big effort to do this using video conferencing and doing it in a distributed way. And what's really interesting about TBI is that it's by far the most successful like educational technology of all time. They found that they could take, you know, C students and consistently make them B students, D students and consistently make them C students, which is incredibly good as educational technology goes. Like, you don't expect to see like whole grade level improvements from any sort of educational technology. And yet they did. They got like, you know, full standard deviation outcome changes, which is massive. And so this is the gold standard in like improving university instruction, is like, can we do anything that is as effective as TBI while being less resource intensive? That's the main problem with it, is that for every 5 students in class, you need an hour of a GSI for each lecture. So for this class, we would need, you know, 20 GSI hours for every hour of lecture, which means we would need, you know, 60 GSI hours a week just for that, which is basically my entire GSI budget. And so it doesn't work out in terms of kind of practical reasons, but in terms of just educational performance, it was amazing. So one attempt to kind of capture that magic in a more distributed manner was Live Notes, which is a project that was done here at Berkeley by a fellow named Matt Cam, just before my time at Berkeley. And they did all of their experiments in this very room. You're part of history, where they handed out early tablet PCs to everybody. We're talking 2001, 2002, something like that. Early tablet PCs to everybody, and they were loaded up with the lecture slides for the day. And during the course of the lecture, students could take notes on each slide, either directly on the slide or in the margins. And those were shared with a small group within the class. So you would be randomly put into a group with like 4 other people in the class, and then you guys would have a shared workspace. And you could, make notes, and you could talk to each other, and you could be like, I don't get this. Do you get this? No, I don't get this. And in theory, the GSI was supposed to be sitting over here, like one GSI was supposed to be flipping through all of the groups, looking for confusion, and then like waving their hand to the professor and being like, hey, they don't understand contextual inquiry. Like, can you go back over that again? And it wasn't bad. It worked well enough that like they got some results out of it and they got a paper out of it. And that's good. But you will note that you're not all sitting here using live notes today, which means that it can't have been completely successful in terms of like changing the world. But there's lots of these kind of notions, like how do we augment the lecture space to capture some of what's good about TDI without completely overloading the course staff? Cool? Yeah.
Why did this fail?
I don't know that it did fail, actually. I mean, it did pretty well. You can read the paper. It's really interesting if you Google live notes. I would say it was pretty damn successful, actually. And the reason that it didn't go anywhere is because nobody made a company out of it. Like, that's the only way that kind of grad student projects survive, is if that grad student and their advisor or some other people like go out and make a company out of it. And especially at the time, whoops. Dear God. Go away, Will. Anyway, especially at the time, education was not in. Frankly, it's why I'm not still in educational technology, is like there was no money to be had in it, especially 10 years ago. And so it just didn't. I mean, that's all there is to it. I think if you revived this right now, it would probably go better today than it did then, actually, because you could just give everybody an iPad and they would communicate with each other, and probably it would be a good thing. Yeah.
Is Khan Academy a bigger distributor of this, or Khan Academy and all the other?
Yeah, we'll get there. But I do think that you could improve kind of flipped classrooms by doing things like this. Cool. All right, totally different topic. Metacognitive systems. So I mentioned before that like learning happens best under the context of like active reflection, kind of pausing every now and then and taking stock of what you've learned and what you haven't learned. And so there were a number of these projects to like really teach students how to be learners, teach people how to learn. It turns out that more than anything, this is really what like makes or breaks elementary school students. So if you go out there and work with elementary school students, or God forbid, have little babies running around, like be aware that like if you can teach your kid anything, it's like how to reflect about their own learning process. That's more important than basically anything else at the elementary school level. And so this would force students to like stop, make a hypothesis, test the hypothesis, reflect on whether their hypothesis was reasonable, reflect on how they changed the world and what they've learned. So that's metacognitive systems. Kind of cruise through a few of these. Inquiry-based systems are along the same vein, where you just force students to stop and ask a question before proceeding. And so there's all these inquiry-based systems out there. And inquiry-based learning, I would say, is the big survivor out of this batch. There's still a lot of inquiry-based learning going on out in the world. Thinker Tools was the like original innovator on this. where you explicitly like ask the student a question, ask them to predict the outcome, have them do an experiment to determine whether they were right, model how that might apply to other situations, apply that model to how the world works, and then give them another question. And so it's basically iterative design for comprehension. It's about kind of continuing to hammer on these notions until you're really sure you have the right idea. Skip that. Another one of these deals where we're kind of back to like graphical physics simulators and things, because you almost have to have a simulator of how the world works in order to do inquiry-based learning. You can't ask somebody a inquiry-based question about like philosophy. It just doesn't work that way. But you can ask them an inquiry-based question about like a chemistry lab. What would happen if I mixed blue and red? And the student be like, I think it blows up. And you're like, all right, try it. Report back. And so you can do that in the physical world, and you can do that in these sort of simulated environments. Based on what I just described about like, so the keys here are rapid feedback and the ability to kind of simulate. What might that make inquiry-based learning a good paradigm for teaching? What topic? A topic near and dear to our hearts. Programming. It happens to be a very good, very, very good model for teaching programming, because it's very easy to make changes in the simulation, right? In the physical world, if I ask you, like, what happens if you change x less than 8 to x greater than 8? That's something that you can really quickly test. It's very easy to kind of go through this cycle of questioning, predicting, experimenting, modeling within that context. Skip that, which is why inquiry-based learning has had, for a long time, become a big thing here in the CS division. So UC-WISE was this like inquiry-based method of teaching computer science that still has a lot of proponents around the country. It's not quite as alive here at actual UC anymore, but it is still used kind of widely throughout the world. And so the point here is that it's worth knowing that like learning management systems, so things like WISE, which is an inquiry-based learning system, UC-WISE, which is built on top of that, Sakai, which was the old B-Space, or Canvas, which is what B-Courses is built on, are all intended to kind of reflect one pedagogical approach to the world or another. Some of them do it better than others. So like UC-WISE was a very strongly inquiry-based thing, whereas trying to like discern the pedagogy of Canvas is very difficult. It's kind of just a generic content management system, but it's there. And we'll talk more about how Lecture has changed over the years after Administrivia. Cool. Great. All right. In case you haven't heard it enough times, final presentations Thursday, May 7th, 11 a.m. to 2 p.m. over in Hearst Memorial Mining Building. Half the class will be doing posters, half will be presenting, and we'll flip. I don't know entirely how that's going to work, but we'll figure it out. Friday, pilot usability study is due. The goal here, more than anything, is just to get you some practice doing user studies, because if you go out in the world and try to represent yourself as like a UX person, you will be expected to like know how to do this. So get some practice, work on your like think aloud procedure, and all that sort of stuff. The other thing I will warn you is that people who can't think of a better question at presentations and poster sessions will always ask you, how did your prototype change based on what you learned in your user tests? That's like the go-to question at a poster session. So anticipate that question and try to like actually learn something from these user studies. And you should be continuing to iterate over your prototype. So improve, take the feedback from your peers and from the core staff that you should have gotten on Piazza, and let us know if you have any questions. Final project, let's see. So you'll arrive at the final version of your prototype, deliver a 3-minute presentation of your project to the world, and then host a poster session where you show a live demo. This is from like way back when at the beginning of the course, just revisiting this. And then you will make a 5-minute video describing your whole thing and then submit your source code. And just to remind you kind of what our criteria for grading is, some of your projects are in better places than others, honestly. Like some of you have been more ambitious, some of you have more polish. Like different teams are in different places on different aspects of this, but like some of you are too low across the board right now and need to kind of step it up. Like I can understand like trading some visual polish for some functionality or vice versa, or having a deeper, broader, richer experience at the cost of something. But like if you suck on all of them, like you're not going to have a great grade. It's just how it is. Like if your project doesn't impress people, you're not going to end up at the place that you want to be at. So the broad criteria are ambition, completeness and polish, usability, utility, and visual and aesthetic appeal. Questions about that? Just bear in mind, grading will be very holistic, and a lot of your grade is kind of coming down to like, what do the GSIs think of your thing? Like, are they impressed or not? So get to it. If you're concerned about your project, come and talk to us. I've got office hours today and Thursday, and GSIs have office hours all the time, and we're easy to get a hold of on Piazza. So if you have concerns either about your group or about the direction of your project, or you're not sure if you're in the place you should be in yet, then just come and talk to us, okay? All right, no excuses. Cool, so for the last little bit of this, I'm going to talk about lecture alternatives and content creation, which is getting into my actual dissertation work. So we talked at the beginning of this about how lecture is bad, and yet here we sit in lecture. And we're going to dig into kind of why is that? Why haven't things changed faster, and what can we do to push people in that direction? So various solutions to this that have been proposed are things like lecture technologies. So we talked about live notes. There's also these peer response systems, and there's various ways of kind of engaging students in the classroom. So I could break you up into groups, and then we could do group work, or there's lots of different ways we could go about like getting you more excited about lecture. But they're challenging and they're time consuming, and they don't actually work all that well, as it turns out. Live notes is pretty good. These are pretty bad depending on how you use them. One of the bigger initiatives that ever took place here at Berkeley was lab-centric instruction, which is UC-Wise. Have any of you been around long enough to remember UC-Wise or lab-centric instruction? All right, a few of you. That's cool. So it used to be that CS3, back when CS3 was a thing, and 61B and 61A, and for one semester 61C, were all taught in this lab-centric model. And the idea was that each class had 1 hour of lecture a week and then 6 hours of lab. And the 6 hours of lab was required. The 1 hour of lecture was not. And everybody had to sit in the computer lab for 6 hours and work through step by step, a course. So think like an online course, but you had to all do it at the same place at the same time, sitting in a room together, working on computers. And the idea was that the GSI could be sitting there and watching the results come in as you were doing exercises or quizzes or whatever. And then the GSI could be like, wait, you guys don't understand floating point numbers. Like, let's have a little mini lecture about floating point numbers, or let's discuss that. And so it was this clever idea about how to get more tools into the classroom, get people engaged in like actually doing things in class, and then use the GSIs as a resource in the most effective way you could. And this isn't going away. Like while lab-centric instruction as itself is kind of faded, we still do have kind of studio-based courses and more hands-on courses and things like that. This notion of kind of lab-centric instruction and things around it, along with the advent of Khan Academy and some of the other online courses, led to this proposal for the flipped classroom. Raise your hand if you've heard that term, the flipped classroom. Okay. This was a big thing 4 years ago, 3 years ago, where the notion was that you wanted to have all the time, all the contact hours, so time that students were in the same place as course staff, be it the professor or GSIs, to be focused on activities and like active learning. And so they would have labs or studios or whatever for these contact hours, and then they would put the high-level abstract content into videos that students could go off and watch on their own time. And so this is still a thing. Like there's still schools out there doing flipped classroom sort of work in universities and in high schools, and it's okay, it's a good thing. And then the kind of big revolution over the past 5 years is the advent of the MOOC, the massively open online course. I will not dig too deeply into MOOCs other than to say that I'm the leading skeptic, maybe. I'm among the leading skeptics in the world on MOOCs, and part of why I'm not still like an academic researcher is that the world was going in this MOOC direction, and I got so incredibly pissed off about it that I left. But basically, the people who realized, like, wait, we can be shitty teachers for 100 people, we can be shitty teachers for 100,000 people, don't inspire me to greatness. And so that's kind of where we are there. They are going through the same process that the rest of the world went through over the past century, where like, now they have all this data, and they're like, after like 2 years, they're like, wow, nobody's learning anything from our lectures. We're like, yeah, we could have told you that. Like, the science is not out on that. Like, we knew that already. And so now the people who are interested in MOOCs are kind of iterating over that concept, and maybe they will end up at someplace interesting. They're not there yet, I can say with some confidence. Right now, they are still kind of in the 1909 iteration of like what course design looks like. They just happen to be broadcasting it to 1,000 times as many people. Yep.
Do you think this would be successful if you have like really good teachers?
No, that's not the problem. The problem is that you have to do a different style of teaching. Like, it's not a matter of like how good is the lecturer or how good, even to some extent it's how good is the content that they're creating. But it really is about engaging people in a different way. Like, if you can simulate studio time to 100,000 people, that's compelling. But that's not just a matter of like, get a better teacher. That's a matter of like, completely change your infrastructure. And so we're not there yet. And I hope that the people that are in this space like take the lessons of the past 40 years of educational technology to heart as they go off and kind of try to improve these things. Like, I wish them well. I want these things to succeed, but they're not ever going to succeed just by broadcasting lecture to more people. Anything else on that? All right, so digging into a different direction, why are all of these things not enough? Like, why do classroom technologies, instructional technologies, not kind of fundamentally solve the problem? And the reason is that, as I was alluding to there, instructional technologies and MOOCs are content delivery platforms, but content delivery is like at most half the problem. The big problem in kind of education is content creation. That's the really substantial challenge that faces people. And it's worse at the university level, where most people teaching courses don't have a whole lot of background in education or like how people learn. Professors are in no way required to learn anything about how people learn. That's not a requirement for the job. Many professors have never taught before when they go and teach for the first time. Have never had any like training or hands-on or anything like that. And so building content is really, really ultimately the challenge. And it turns out that content creation is very difficult. Like even just doing, let me tell you, like even just doing this, like this is relatively easy, like lecturing 2 times a week. And even this is a bitch in terms of like the content creation process, because I have to sit down and I have to make 6 hours of content a week. And that's like a job, it turns out. And it's much worse if you want to use these like engaging classroom technologies. So making like a week of lab-centric instruction, like UCY's material, can take 80 to 160 hours easily. So you're talking about 4 weeks of full-time work to make 1 week of UCY's content, basically. And engaging people in that process is just awful. Like going to just some, imagine you have a luminary researcher in computer science, going to them and saying like, all right, we want you to teach in this new format. By the way, you're going to have to work full time on it for like the next year before you can go and actually teach it, is just never going to happen. And so you really want to push people in the right direction, because it's very easy for novices to misuse classroom technologies. That's kind of what happened to peer response systems, the clickers, is that nobody knew how to use them right. If you want to use peer response systems right, you do it at the beginning of class as a reflection over the previous day's material. So as soon as people come in, you ask them some question about like what they were supposed to learn before, and you see if they know it, and if they don't, you like go back and review. But what everybody actually does is put it at the end of the class and just uses it for like taking attendance. Not so good. The other challenge is that it's difficult to tell what aspects of a good design make it a good design. And the reason for that is that design is famously a wicked problem. It's wickedly difficult to design content. It's wickedly difficult to design anything because it's hard to know when the design is being done right. It's difficult or expensive to iterate over solutions, and it's impossible to know when you're done. And so the way we usually learn to design is through studios and apprenticeships and courses. But you're never going to get like computer science professor to sit down and take a 6-month-long studio on how to be a better teacher. It's just not going to happen. And worse, designers can never stop learning. So what it means to be a good designer and what it means to have a good design continuously changes over time. So paradigm shifts are just constantly changing things as we move to different types of software engineering and different types of product development and different types of instructional design. And so traditional teaching methods are not really oriented towards people who are out there working, who are practicing designers, because they're too time consuming to do while also being a full-time employee. They usually require some sort of synchronous collaboration with teachers and peers. And the best types of learning also have to be co-located, where you are working with peers and teachers in a single room. So we are now venturing into my dissertation territory, so beware, there be dragons and such. But my contribution to the world, such as it was a model called virtual design apprenticeship. And the notion here is that it is a way of trying to capture the good things about kind of apprentice relationships, like master-apprentice relationships, between expert designers and novice designers, without requiring co-location and without requiring like permanent dedicated relationships between a master and an apprentice. And so it's all based on work that I did here at Berkeley and elsewhere, where we wanted to capture these goals, getting the benefits of apprenticeship in studios. And the model, in one slide instead of like the 60 that I gave on this when I gave my actual dissertation defense, is that the key to the whole thing is having annotated design artifacts. So imagine that you had a outline of a course, or you had a diagram of a product design, like a patent sketch, and you took that artifact and you gave it to the person who created it, who was an expert, and you ask them to just go in and like label the crap out of it. So tell me absolutely everything important about your design. Like tell me why this is good and why this works and why you didn't do this other thing and what works and what doesn't work. And you get towards a teaching method called a case study, which is this kind of dissection of a real world living artifact. But instead of putting it in kind of a book format, which is what a case study is, you put it in this like annotated diagram format. And so it turns out that it's very difficult to do this in a kind of free-form way. And so it's much better if you can give people a fixed set of annotations and then ask them to apply those annotations to their own artifacts, to their own designs. And we'll talk a little bit about how we did that. And then you get together some collection of these annotated artifacts, and you put it into a repository, and you hand that to people who want to learn. And you say, like, these are good examples. They are well annotated to kind of explain why they're good examples. And they are built on top of these like common principles. So, you know, if the principle in like an educational design is, you know, gather feedback early as opposed to gather feedback late, you know, learn what your students understand as soon as you can after you taught them, that might be a principle, you know, that you label a part of the course with. And as you look across a number of different courses, you can see that principle applied several different ways. And the notion here is that we're following this progression from concrete to abstract that we talked about earlier in this lecture, where we're going from very concrete examples of like, here is a place where we did this good thing, out to here is the good thing in principle in the abstract that is being applied across a number of these courses. So that kind of emerges from having this repository. And then you build a community of experts and learners where the experts are generating the annotated design, the learners are consuming them, and then the learners are providing critique and data and other types of kind of useful feedback back to the experts. And so it looks kind of like this in the big picture. You have your adopters who are just taking taking the experts' artifacts and then giving them some feedback on like how it worked. You have the like more engaged adapters who are taking these things, changing them, contributing them back to the community, and then getting critique from the experts. You have the combiners who are getting lots of these annotated artifacts and kind of assembling their own thing, contributing it back and getting critique. And then you have creators who are, based on having learned from this process of working with these annotated artifacts, now capable of making their own unique artifacts and kicking them back up into the world. And this is how kind of a novice becomes an expert and moves into the community of experts. The kind of HCI computer science bit of this is that you need tools to mediate these relationships. So, excuse me. So you need some sort of design tool kind of in the loop here in order to help the person actually do the artifact annotation and search over annotations and kind of parse out what they can learn from an annotated artifact. And that's where I built this tool called PACT, Pattern Annotated Course Tool, that does all of these things. It enables artifact creation and annotation, facilitates sharing, makes them usable in the real world, makes exploration and comprehension easy, encourages experimentation, structures the community, and helps you use good designs as templates for new designs, that sort of thing. And so we ended up with this thing called PACT, which is this little guy up here, which is all about being a curriculum authoring toolkit. So you can drag and drop content here, and it changes the real world. We were using Moodle as our backend, but you could use a number of different things. Excuse me. All right, we're good. And then you get these annotations that I'll show you in more close-up in a second, Where do those annotations come from? They are kind of abstractions of best practices in learner-centered instruction, formalized as these design patterns. So if you've learned anything about like design patterns in the context of like software engineering, same general notion here, where we are doing design patterns for instruction that are templates for building good courses. And so this is way too much text to read, which is kind of the point, but it's a pattern describing kind of how you should get feedback to students early rather than late. And then we go from those patterns into kind of concrete annotations where you can apply them directly to the content to make expert thinking visible. And this is scaffolding to help somebody progress from concrete to abstract learning. And linking the patterns with the instantiations makes both the patterns and the content easier to understand. And so we get in here and we have these like very specific annotations attached to pieces of content. So over here we have linking old to new, where we review and then introduce a new topic that's related to it. Here we have just kind of free form annotations for collaboration. Here we have what we call trend patterns, which are just like, do you have the right amount of this type of activity going on in the course? And then we have these one-off patterns like lay of the land, where we talk about the high-level goals of the course. And so the results of this, I built this thing, we ran a bunch of studies, and we found that curriculum developed with the help of pattern annotations is better curriculum as judged by experts, that people who work with annotated courses understand pedagogical design better, and that annotated examples are perceived as more credible and convincing than non-annotated examples. Questions about that? Okay, I think my voice is done. Yep. In terms of annotated courses, or the community side of it more than anything. So how you incentivize and engage a community in the process of like building annotated artifacts and then critiquing other people's annotated artifacts. Turns out it works really well in this like little subset of the world where people really care about how good their artifacts are. So like if you are trying to publish a result based on like claiming that you have invented a new way of teaching, for instance, then you would have very high incentive to like build an annotated course, share it with the rest of the world, and then get feedback on it. But if you're not in that context, and in particular if you're in a more industrial context where you're being a little more secretive, then it's hard to get people to like actually engage in this community process. That was the biggest open question, actually. It's just about user engagement. In terms of the actual like process itself, it actually works really well. And indeed, I still use this technique a lot. So at Canoma, for a while, we were building all these annotated code samples, which were code samples with like design patterns explicitly annotated on them. And it worked really, really well. This was on our previous framework. We had these, our framework changes about every 4 years, but the previous iteration, we built all these annotated code samples for and shared them with the world, and people learned from them really well. And I would like to go back to that at some point when I have a little bit of time.
Do we have that for our framework?
We do not, because Andy doesn't have any time to do such things right now, which is the other problem with building the community. Like, ain't nobody in the world cares more about annotated artifacts than I do. And even I have trouble finding time to like actually build these things, because it really is a process. Anything else? Okay, there is a reading assignment for Thursday. It's fun. It's my all-time favorite HCI thing in the world. So read it, enjoy it, post your response for Thursday. Thursday, we will be doing historical perspectives, so just kind of a little history of HCI and like where it's going. Next week is still a little bit up in the air. We had a plan for Tuesday, and then that plan fell through. So I'm trying to come up with a new plan. Either we are going to have a panel of like people talking about IoT startups, or we're going to have like nothing. So I'll let you know which of those it's going to be at some point soon. But wish me luck on putting together a panel at the last minute. Otherwise, I think what we would do on Tuesday instead is just have as many of the GSIs here as possible to do kind of critique and discuss like where your prototype is at, if that will be helpful. And then next Thursday will be the last day of lecture. HKN will be here, so if you want to tell them how terrible I am, that's next Thursday. Or if you like me, you can say that too. It's allowed, I suppose. And that lecture will be kind of a summary of the course and forward-looking, kind of what does the future of HCI look like and where's the research going. Any other questions? All right, thank you for bearing with my half voice for most of this class. See you Thursday. If you didn't pick up your group's feedback, it's up here. Or somebody took it. Was it?
So you're also now, right?
Yeah.
That comes back to the using separate files stuff.